What up, athletes? Whoop, whoop. All right, let's get into this. This is 2.7 using formulas, and it's going to be amazing. So just keep that in mind. All right, I know I got my picture down here. It's because I want to do some work up here. Today is I will solve equations for a specific variable and convert units, translate these verbal expressions to equations, and solve them. Ready, set, go. Oh boy, reach into my bag of tricks. Grab a coffee cup. Feel free to fast forward this if you paused it, because I need some coffee. All right, well, we got to get into this. You'll have a little more room than I do. This is an earlier draft. 3 times n added to 5 is equal to 7. So we're going to have 3n plus 5 equals 7, correct? And this isn't too bad to solve, is it? Just subtract 5, boom, minus 5. We get, oh, that's negative 7, by the way, equal to negative 7. I almost did that wrong. So we're going to have 3n, boom, that's gone, equals negative 12, which divide both sides by 3, and you get that n equals negative 4. Boom. Negative 4 less. Now, notice this doesn't say less than, it says less. So it's just like negative 4 minus 3 times a, and then is the same as is equals 2. So we got negative 4 minus 3a equals 2. Again, add 4 to each side. I can take more room because you got to write vocab, so be careful. I've already got vocab filled out on another page. And when I divide both sides by negative 3, I get that a equals negative 2. Boom. The difference between, so I'm going to subtract these, 67 minus 5c equals negative 28. Again, let's subtract 67 minus 67, which is going to be what? Negative 95 minus 5c equals negative 95. Divide both sides by negative 5, and we get that c equals positive 19, because a negative divided by negative is positive. And last but not least, when the sum of w and 7, so that's what? W plus 7 times 9 equals 207. So I'm going to distribute that 9, and I get 9w plus 63 equals 207. And when I subtract 63 from both sides, I get that 9w equals 144, or w when I divide by 9 equals 16. Boosh, right there. I know you couldn't see that, so sorry. Okay, careful with your spacing. You're not going to have a lot of it, but you do have more than I do, because again, I did some edits to this. But go ahead and write down this vocab. I'm going to put it up here. Move my picture out of the way now. So we have formula, and what is formula? It's an equation that expresses a relationship between certain quantities. We have literal equation, which is a formula or equation with several variables. And we have dimensional analysis, which is the process of performing operations with units. All right, again, pause this. We're going to get rolling on with the rest of this. Ready, set, go. Okay. So now I want to take a look at solving for a specific variable. So these are literal equations they have, which just means they have more than one variable. And this one tells me to solve for a, so I want to get the 5a by itself. To do that, I got to move 2b over, plus 2b. And I like to put those terms in front anyway. So I'm going to go 5a, boom. Those can't combine, so I'm going to say equals 2b, and that's a positive 15, so plus 15. If you want to put 15 plus 2b, I don't care. I just like to do it this way personally. Now I'm going to divide by 5, and I'm going to distribute this division because I know 5 goes into 15, and I want to do that. So I end up with a equals, now it depends on how you want to write it. I like to pull the 2/5 out, 2/5 b plus 15 divided by 5 is 3. I have a reason for that. It has to do with the y equals mx plus b slope-intercept form, but we'll talk about that later. So here we go. Take a minute, pause it, try to solve for x. Ready, set, go. Okay, assuming you use the power of pause. Again, I want to get that by itself, so I'm going to add 7y. And I talked to you, I like to put the variable term first. So I'm going to have 3x, that's gone, equals positive 7y, and then that's a positive 26, so plus 26. Divide both sides by 3. 3 does not go into either of these, so I'm just going to go over 3. And I get that x equals 7y plus 26 over 3. Doesn't have to look pretty. In fact, this next one's going to look the ugliest of all. Hopefully you're doing well on this. Give this one a shot. Get all the p terms on one side. Use reverse distribution. That's your hint. Ready, set, go. Okay, let's try this. So I know I need to get p by itself. But I also need to get this p term over there. So I'm going to get rid of the 7r. I'm going to add 7r to both sides. I'm also going to subtract this pq from both sides because I need to get it over here. Now we want to be careful. Listen up. I cannot combine these. 4p and pq, there's a q in there. There's an extra variable. I can't put those together. So I'm going to have to write it down as 4p minus pq. That's gone. Equals, that's gone. And I like to put that first, 7r and a plus 16. Now they both have a p in it, so I can pull a p out. When I pull a p out, I'm left with 4 minus q equals 7r plus 16. Look at that. And guys, don't freak out about this. It's in parentheses. It's a single number. At the end of the day, we're going to pick a q. Maybe it's 2. It'll be 4 minus 2 is 2. We're just dividing by everything in the parentheses, 4 minus q. Because a number next to a parenthesis means multiply, so I'm just undoing multiplication. Dividing by 4 minus q. Don't have to put it in parentheses, really, because being under a fraction bar means it, but I do anyway to start off with. And now, what I'm going to do is go, all right, that crosses out. I'm left with p equals 7r plus 16 all over 4 minus q. Again, they don't have to look pretty, but it really was just addition, subtraction, division. That's it. That's all we did. Well, I guess, and reverse distribution. Don't forget that step. Awesome. Let's look at this one right here. The area of a trapezoid is height times base 1 plus base 2 all over 2. Which, guys, remember a trapezoid. We have our height, right? And we have our base 1 up top and our base 2 on bottom. That's all we're saying, okay? And then A is the area, represents the area. H represents the height. B1 represents the length of one base. I do the top. And B2 represents the length of the other base. I do the bottom. Solve the formula for H. Okay? So if A equals height times base 1 plus base 2 all over 2, use the last one as your guide. First thing I'm going to do is multiply both sides by 2. You can put it over 1. Don't need 2 over here. And I end up with what? 2a equals, those cross out, so height times base 1 plus base 2. Boom. And then, just like in the last one, I want to get height by itself, so I'm just going to divide by base 1 plus base 2. That's it. This one was much easier. Those cancel out. Now I'm going to switch sides and say h equals 2 times, oh, I should have used a capital A over here, by the way. It matters. You will get marked wrong in your work if you use the wrong case. 2a over base 1 plus base 2. Boom! Look at that. Amazing. Last, we're going to talk about t-shirts here. And let's talk about it. So we say Carter is creating a t-shirts for a pep rally. A little bit extra room there. I don't know why I took a picture. It's weird. But the total amount of money Carter collected from t-shirt sales is T equals 1495X plus 1995Y. T represents total amount of money Carter collected. X represents total number of short sleeve t-shirts sold, and Y represents total number of long sleeve t-shirts sold. If the total amount of money Carter collected was 698, so that's T right there. Find the maximum number of short sleeve shirts, that's X, Carter could have sold. So let's see. First of all, let's go ahead and look at that equation. T equals 14.95x plus 19.95y. I want to solve this for x, okay? So I'm going to subtract 1995y from both sides. And I'm going to switch sides on it. Well, no, not yet. So I'm going to get t minus 19.95y equals 14.95x. And I'm going to solve for x, 14.95. Divide that whole thing by 14.95. Boom. And I get x equals t minus 19.95y all over 14.95. Now here's what I want to talk about, guys. Check this stuff out. If I do this, and I want to find the maximum number of short sleeve t-shirts, that means I want to get rid of as many long sleeve as possible because long sleeve is more expensive. Therefore, for every long sleeve I buy, I could have bought one more of these, right? So I'm going to say, all right, I want my long sleeve shirts to be 0. So if that's 0, I end up with what? I end up with, I know my T is 698, so I'm going to have X equals $698 minus 1995 times 0, because I want 0 long sleeve shirts. And I'm going to divide all of that by 14.95. Well, anything times 0 is 0, so I'm just left with 698 divided by 1495. You see how that works? Boom. So I'm going to have $698 divided by 14.95. Now, I can't buy 0.68 of a shirt, so I'm going to just say is approximately 46. That was 46, right? Boom. So, Carter sold a max of 46 short sleeve shirts. Boom. There we go. We manipulated it. We used our intelligence to say long sleeves is 0. And then we solved for the amount of shirts he could have sold at max. All right. Boom. Let's go on to page 2.